About Lewis bond theory. Lewis was a scientist who was well known for his discovery of covalent bond and the lone pair. So what he gave the structure only shows the outermost electron. He gave structure that only shows outermost electron. Only shows outermost electron. Okay, one thing, the basic point that I'm writing here, then we're going to start the structure, how to make the structure of the like molecular compound that we'll be discussing, and ions and all that. Okay, so first is it works on octet rule. What does it mean? Means in each atom the structure must have 8 electron in their outermost shell. For example, 2 electron, 8 electron and 8 electron. So all the elements or an atom must have 8 electron in their outermost shell except hydrogen. We are pretty aware that hydrogen has only 2 electron in its outermost shell, which is duplet. This is extra. Okay, octet rule can be, okay, the second point is it should have 8 electron in outermost shell, but this octet rule can be neglected for the central atom. This rule can be neglected. What does it mean? For example, the central atom always try to remain in maximum covalency. Now what is covalency? Maximum covalency. So the central atom can have 8 electron or more than that. It's not important that the central atom exactly should have 8 electron in its outermost shell. It can have more, it can have less. That's depend. Okay, on the situation or meaning of the bond, right? So what is covalency? Covalency is the sharing of lone pair or bond pair. Sharing of lone pair and bond pair of electron. Sharing of lone pair and bond pair of electron. Bond pair of electron, right? So this is some basic point. Now we're going to talk about the rule for selecting central atom. Rule for selecting central atom. The first is it should least in electronegativity. What is electronegativity? Least in electronegativity is basically a tendency of an electron, it's a tendency of atom to attract a shear pair of electron toward itself. For example, fluorine has maximum electronegativity. Fluorine, then look, it's like fluorine, then chlorine, then bromine. It's just like this. Okay, so now we're going to talk about the second. If the electronegativity of the atom is same, then we will I'm sorry, my mistake. The first is we should select the atom which is least in number. That's the second priority that we consider least in electronegativity. First is okay, I'm writing here neat and clean. The first is, okay, select atom which is least in number, right? In number. The second point is if the atoms are present equally, like C2H2, like for example, we get more examples of O2. Now the second priority is select atom which has least electronegativity. Select atom which has least electronegativity. If the electron, just like this atom, it has equal electronegativity. Now the third thing that we give that we should give priority is that size should be largest, and if the size is also same, then we're going to give priority to highest atomic number. These are the 4 series that we follow accordingly. Highest atomic number, right? And the basic point that I have already discussed in this video, that the central atom can have more than 8 electrons because it's try to remain its maximum covalency. For example, maximum covalency of oxygen is 2, sulfur is 6, nitrogen is 5. It can sulfur can have 4 bonds and 1 lone pair. Unlike sulfur, nitrogen can have 3 bonds and 1 lone pair. Okay, Now I would like to tell you one thing, that it can never be pentavalent. Nitrogen can never be pentavalent, because it can have 3 bond, 1 lone pair, or 2 bond, 1 bond, 1 lone pair. Okay, so now I would like to talk about variable valencies. That variable something means change, that changes, right? So as I said, the central atom always try to remain on its maximum covalency. Now I will discuss some important atom here. The first is oxygen. Its variable valency is 1 and 2. Now I'm going to tell you some key points as well, so that you can easily identify without calculating your charge or the valence electron or the formal charge on your on atoms. You can easily identify from where we have to plot this +1 charge or -1 charge. Just tricks that I'm sharing here as well. Sulfur 2, 4 and 6. Nitrogen 3 and 4. Carbon, I'm sorry, 4. Sulfur, it's 4. Silicon 4. Chlorine 1, 3, 5, 7. 1, 3, 5, 7. It's 1, 3. Okay. Phosphorus 3 and 5. Okay, one more key point. If like N, we can SO4 plus 2. Okay, so if positive charge is present, right, plot on the central atom.